All right, our last stop today is the concept of the discriminant. Let me write that on the board for you. The discriminant actually tells you about the behavior of your quadratic function. And it actually comes from looking at the content underneath the radical of the quadratic formula. This b squared minus 4ac. If you remember in that last example that we did, we actually ended up with the imaginary answer. And we only can get imaginary answers if underneath that radical we get a negative number. So if b squared minus 4ac is less than 0, we are going to have two imaginary solutions. Okay? Now if we had been a positive answer, we would have ended up with two real solutions. b squared minus 4ac, if it's greater than 0, we would have ended up with two real solutions. And then we would have to simplify the radical. Now there's one other case. If we end up with a 0 underneath the square root, well, the square root of 0, no matter what is 0, you can't have a plus or a minus. It doesn't matter. Adding 0 and subtracting 0 is the exact same thing. So we have b squared minus 4ac is equal to 0. We're going to have one real answer. One real solution. Okay. So these are your discriminants. If we're negative, we get two complex answers. If we're greater than 0, if we're positive, two real answers. And if we are exactly equal to 0, we have one real solution. Now, I don't have to present these to you exactly like this. Let's look at this bottom here. What would make this true? Okay. What makes us have this equal to 0? b squared. If I want to get them by myself, I can add 4ac. b squared equals 4ac. So b squared is equal to 4 times ac. I know I'm going to get this equal to 0. I can move these around however I want. I can change them however I want. I can present them however I want. Now I'm going to go one step further and give you a little bit more about where these are going to be heading. Imaginary answers. Imaginary answers do not appear anywhere in our real Cartesian plane, in our real number plane. Okay? So when we go to graph parabolas, I had mentioned earlier that zeros are the same as x-intercepts. Well, if we have two complex solutions, which is two complex intercepts, we'll never cross over the x-axis. If we have two real solutions, that means we're going to cross over the x-axis in exactly two places. And if we have one real solution, one real x-intercept, that means we can touch it in exactly one spot. That is essentially what your discriminant means.